So today we will see the fluid flow simulation in pipe with sudden contraction. So first of all, start with the ANSYS workbench. So this is 2022 release 1 version. So you have to select the fluid flow Fluent option available in the analysis system. Select on this. So you have geometry, mesh, setup, solution and result. So one by one we'll start preparing the geometry of sudden contraction. So first of all, click on any one of the plane, select the units. Say for example, I have selected centimeter. Then go to the primitive, select a cylinder. Now this is oriented in Z direction. I don't want this in Z direction. Say I want in X direction. So we'll specify this as X. We'll make this as equal to 0. So now you can see the object has been oriented in X direction. So we are interested in the fluid flow simulation which is taking place when the fluid is flowing through a pipe which is subjected to sudden contraction. So that is we are going to see. So I'm specifying the X component, say somewhere around 40 over here. I'm just changing the radius to somewhere around 5 and let's make it generate. So make this as add to present so as to have better visualization. So right now I have not specified as a hollow. First of all, I will create the geometry and then we'll specify the thin surface. So one more time, selecting a primitive, that is a cylinder. So again, I don't want this to be in Z direction. I want this to be in X direction. So over here, make Z component is equal to 0. I don't want this to be in that direction. I want in negative direction over here. So I specify that. Now we'll change the radius. Earlier I had taken 5. Now I take it is 10. So another solid object is generated. Make it add to frozen so that the transparency will be better. So you can see the two objects has been generated over here. This is the solid, another one is a solid. So right now we haven't made it as a hollow, but we need to make it as a hollow before proceeding for our, we can say, analysis. So this is a dimension we have taken. You can change your dimension also as per your requirement over here. So first of all, these two things which we have created, I will just go on to make as a Boolean operation. Why I am going to make this as a Boolean operation? To avoid the errors that can happen when we are filling the fluid inside. So I'll make it generate. So you can see one part over here. Now I will make use of thin surface. So click on the surfaces which okay, so this is select as a faces to keep. Select the faces. Select this face also. Make it apply. And you can change the thickness, say for example 2.5. So let's make it generate. So you will see now this is a hollow pipe with sudden contraction has been prepared. Now this is the first phase. Next will be to fill a fluid inside. So try to select the internal part, say this one and this one. Make it apply. Let's make it generate. So what will happen? This is your fluid zone. So let's specify this as a fluid. Say for example, if I am considering water as a flowing, you can specify this is a water. So this you can specify the pipe through which the fluid is flowing. So this is what the first operation. Now next thing is to generate mesh. So click on mesh option. So the mesh, to generate mesh, click on generate mesh. So right now I'm using a default option, default mesh option. If you want, you can change the size of mesh as per your requirement, but to reduce the computational time, I'm just taking a default mesh. So again, now we need to specify the which one is inlet, which one is outlet. So we'll specify the face over here as inlet. So create name selection, specify inlet over there. Then on the other side, select this as a outlet. So this is your outlet. Then remaining, it is your wall. So I have specified as a pipe wall over here. So once upon click on update, you will see a message. The mesh translation to Fluent is successful. So once this is done, you can close this meshing window. Next, in front of geometry, you are observing right click. In front of mesh, you are observing right click. Let's move to the setup. So you have to select double precision depending on whatever number of processes that you can run. You can select that. So make it start over here. Then the Fluent window will open. Now in the Fluent window, we need to apply certain boundary conditions. We need to specify the fluid which is flowing through this particular pipe. So you can see the arrows. What this arrow will indicate you the inlet and outlet. So I will specify gravity. Now in this case, as the fluid is flowing in horizontal direction, we say over there, and again we say the y component here is in upward direction. So I'm specifying minus 9.81. So that is related to your gravity. Then model, I'm not going to make any changes in the model, but in case of material, I will select one more material, that is water liquid over there. So click on that, make it copy, then close, and then close. You will see water liquid available here. Again, the solid I am not changing, keeping as it is. If you want, you can change this also through the Fluent database. Now next one is a cell zone condition. So here again I am not changing anything over there. Just in case of inlet boundary condition, I am going to change few things, that is in terms of whatever velocity I have. So that is I am going to change at my inlet. Say for example I have specified 1 meter per second. Make it close. Now this is the first thing which I have done. Now next thing is a reference values. So we need to tell the computer from where to start. I will say it is inlet. Again reference zone will taken as water. So this is the first thing. Now next will be towards initialization. So compute from, again I will say inlet, make it initialize. So once this is done, you can process with the next part. Okay, so this is initialization we have done. Calculation activities, you can just say take it, say for example 20 iterations, then go to your graphics part, say for example path line. Now what I had to visualize, velocity. So accordingly I will specify inlet, outlet and your pipe wall over here. So accordingly we can specify this one. So make it apply, and if you want to visualize how the things are taking place, you can click on pulse also. So you will be able to see this one. So that will show you how the fluid is flowing when it is subjected to certain contraction over here. So you can make it stop and close it. So this one is done. Now you can go to the run calculation. So you can select the number of iterations over here, say for example 500 over here. Then if you want to see such we can say title, you can click on that and then just click on your generate. Once this is depending on your system configuration, it may take time. Once the calculation is complete, you will see a message window which is appearing over here. so it can take some time. Okay, the calculation is complete. You can further run this simulation also, but I'm just keeping here itself. Now this is in front of solution also, you are able to see right click. Let's move to the next part that is related to your result. So this is the last part which is we are interested in over here. So first of all, click on pipe wall, select the transparency over there. Say for example 0.9, make it apply. You will see the object looks like a transparent one. Again pipe wall, you set some transparency over there. Say for example 0.9. Then inlet and outlet, again you specify the transparency over there. Say for example 0.9. Again for outlet also specify some transparency over there, that is equal to 0.9. So if you don't want to see this wireframe model, that also it can be easily avoided. So this is how your geometry is. Now I will just make it the time step streamline over here. So you can see streamline option, click on that. Again tell the computer from where to start. I will say inlet over here. So this is how the velocity streamline which has been obtained over here. Now if you want, you can just slightly change this legend view also. So how you want this legend, we can say, so that also can be we can say change. Say for example if I specify fixed, you can see this also. If you want number of values to be more, I can say 10. You can increase these values also. If you want to change the aspect ratio, that also can be done. Say for example here I change the aspect ratio, say for example to 1, and we'll make it slightly less over here. So in this way this velocity streamline can be visualized in better way also. Now next thing will be to visualize the simulation. Say for example here sweep animation, so I'm selecting streamline over here. So let's make it slow so that it will be visualized in better way. Then you have to click on this particular part. So click on display. You can see the fluid is flowing, and suddenly when it is subjected to contraction, you might observe some red particles. So what red particles will indicate you? They indicates the fluid particles with higher velocity. So this is a very important thing which we can understand with the help of this kind of simulation. What happens when the fluid is flowing through we can say a pipe which is subjected to contraction. So this is how it can be analyzed. If you want to save the movie, you can save the movie also by selecting a particular folder. If you want to make it say some HD quality video, so that can also be done. If you want to save that's an animation file, that also can be easily done. So just select a new folder in your document. Say for example we are subjected to contraction over here, so I'm specifying the name contraction. Then choose frame rate, you can select. I select 60 over here. Then option I have selected 180. So depending on whatever the orientation we are having, you can change the orientation as per your requirement. Now this is also the folder will specify contraction and will save the video over there. So this is one of the view which I am observing. So just click, okay, sorry, just a minute. So click on this and then just visualize how the fluid flows are been taking place when. So this is going to save our simulation over here. So in order to visualize your simulation, you can have this particular save option which is available on your screen. So this will take time and it will simultaneously go on to save the image file also with respect to whatever the time step with respect to whatever the the sweep animation which we are considered. So it is going to save the video as well as it is going to save the some image file also. So till the time the fluid reach to the other end, the simulation will continuously go on to run. Right now you can see some of the particles are ahead, some of the particles are lagging behind. So the particles which are at the center of this pipe, they are likely to have more we can say velocity as compared to the particles which are near to the wall. So that's why we say the particles which are at the center, it is subjected to we can say less opposition, and that's why the particles at the center, they are having tendency to quickly move out through your contraction. So this is one thing that we have to understand. So that concept can also be basically understood with the help of the velocity boundary layer curve also. So let's you can see the fluid particles which are coming over here, and say some of the fluid particle now will rush. So this red zone will indicate you the higher velocity over there. Initially the fluid particles was having less velocity, but then as soon as it is moving ahead, because of the contraction, the fluid has a tendency to go away from that we can say larger diameter pipe to a smaller diameter pipe. Now some of the fluid particles now will rush to the other end, and you might see some changes in the color also when the fluid is entering into the contraction zone. Carefully observe the color combination of few particles. The color combination has changed. It was earlier it was blue, now it has changed to somewhat green, then it's changing to somewhat yellow, and then it is finally shifting to red. So that will indicates you the higher velocity particle. Again you can see the particles which was along the wall or over there, so they are we say lagging behind, whereas the particles which was at the center, they are quickly moving to we can say the contracted part. So this is how the simulation is there, and with the help of this we can understand how the individual particle behaves when the fluid is flowing through a pipe which is subjected to sudden contraction, as we can see in this particular simulation. So right now the particles which are we say at the center, they are moving ahead. They are we can say with a higher velocity they are moving ahead, whereas some of the particles which are away from this we can say center line, they are lagging behind. So when up to the time this last particle will come out, till the time this simulation will go on to run. And wherever you have saved the simulation, that place you can visualize the simulation in the form of video file which you have selected. So you can see now the simulation has been completed. You can go back to the documents and you can see the contraction over here. So here I will just try to show you one video which we have saved. So you can see how the fluid flow simulation that is taking place when the fluid particles are moving through a pipe which is subjected to contraction. So in this way we can save the video and we can understand the behavior of the fluid particle.